Number 46, write a balanced equation for each of the following nuclear reactions, and then we have letter B. So in this case, it says zirconium-90 and an electron are produced by the decay of an unstable nucleus. Okay. So in this case, we just have to write a balanced equation. We're talking about nuclear reactions, which means that we have to write it in nuclide notation. And nuclide notation always has those three subset boxes, right? I like to put them in boxes, which is represented right here. So let's see where we're going to put this box first. Well, it says that zirconium and an electron are produced. So if you are producing something, that means that you're talking about something that's going on in the products side, right? Produced, prod, even up to here, right? Product, products. So since zirconium-90 and an electron are produced, I know that these guys, right? Both of these are in the products. So we're going to start now with our nuclide notation on the product side. So let's just draw an arrow. And they give us the two products. We have zirconium-90, zirconium, and just as a cool little fact, zirconium is, we see it all the time, right? It's used in jewelry, right? Zirconium, cubic zirconia. So that's coming from zirconium. But yeah, cool. So you're just wearing a metal. Pretty cool. And cubic zirconia comes from zirconium. Since this is a metal, right? It's mimicking carbon, which is the diamond, right? And it's pretty interesting because diamond is carbon, which is a non-metal. Cubic zirconia is coming from zirconium, which is a metal. So it's very interesting to see that metals and a very special form of carbon have very similar chemical properties, but that's just a side fact. But anyway, we have zirconium-90, and then we have that electron. So we just got to write these two out. Okay, so zirconium on the periodic table is Zr. And they tell us that it's zirconium-90. Now, all the numbers that they tell us have to be the mass number. They have to tell us the mass number because the mass numbers can change from element to element. Because you could always change the number of neutrons you have. The mass number is always the number that's on the top of your nuclide notation. So we got a 90 up on the top here. But now the question is, they don't tell us this box, right? And that's the atomic number. Now they don't tell you because it never changes for a specific atom or an element. Number of protons, which is the atomic number, is always going to stay the same. So I have to look on my periodic table to find out what the atomic number of zirconium is. So get your periodic tables out. The atomic number is always going to be that nice, beautiful whole number, not the decimal. That's the average mass. But in here, zirconium is a beautiful 40. So you got 40 protons in a zirconium nucleus. So the subtract of these, 90 minus 40, would tell you got 50 neutrons. Now we have to deal with the electron, right? Another word for an electron is called a beta particle. So whether you want to write the Greek B for beta, which would be this, or if you want to write an E for electron, that's fine with me. Me personally, I like to use the B. When I like to get fancy, I like to get fancy. But you could write the E. Now just know that, electrons, they're not in the nucleus of an atom, so they have no mass, right? The atomic mass is the number of protons and the neutrons. And the charge for a electron or a beta particle is a -1. So there you go with that. Now, we know that we decayed from something, but they didn't say who it was. It just said something unstable. So we have to figure out what the unstable nucleus is. But we can totally figure this out because it's got to be balanced, right? This is a balanced equation, which means that across the yield sign, if we treat this as an equal sign, this equals 90 plus 0. So 90 plus 0 is going to equal, yeah, you got it, 90. Let's do the same thing for the bottoms, right? 40 plus a negative 1, that's 39. Basically, it's 40 minus 1, right? And now the question is, who is this unstable nucleus? Well, remember, the atomic number never changes for an atom. So always use your atomic number to find out who this is. I'm going to go on the periodic table and see who is lucky number 39. And it's one element over to the left of zirconium, which is yttrium. So this is just capital Y. And this now is our balanced equation. So that's it. I hope this helped. Thank you so much for viewing the video. Subscribe to the channel, like the video if you can. Just gets the word out there. We got memberships on the channel if you want to help us out a little bit more. There's 4 different tiers depending on your liking. So thank you so much for considering. And I hope you guys are having a great day. Keep studying hard. I'm always rooting for you on your tests and quizzes. So I'll talk to you soon, okay? All right. Bye-bye.